In this paper, we have 10 new complete mitochondrial genomes from 6 extinct sloth species. For 4 or 5 of these are kind of the first genomes that we've ever actually sequenced from these sloth species. And what's really interesting is when we look at the evolutionary signal in the DNA or in the proteins, it's drastically different than what we recover looking at just the bones alone. And it kind of forces us to really critically reevaluate what we thought we knew about the evolution of these animals, and kind of is the next step in the century-old puzzle to figure out what these species are and where they came from. Another really interesting part of this study is that we have now so many new different species represented, and these species are really interesting. So on this one hand, we have these 2 kind of distantly related Caribbean sloths, which look like they cross over to these Caribbean islands, these Greater Antilles, about 35 million years ago, at a time when they would have been connected to South America, possibly by this massive land bridge. And on the other hand, we have these large, iconic ground sloths that were stomping around the Americas about 10, 11,000 years ago. Among them, Megatherium americanum, the largest ground sloth to ever live. And this thing was massive. I mean, it was 3.5, 4 meters tall when it stood up on its hind legs and weighed as much as an elephant, or as much as the mammoths that were sharing the landscape with it. We've actually used a variety of different samples. So we have, some of these samples are so well preserved we can even find, skin or fur of these extinct sloths. For others, we use kind of more traditional substrates or materials like bones or teeth. And for some of them, we even have to turn to paleofeces, or kind of preserved poop that might be left over from these animals over 10 or 11,000 years ago, typically found in caves like in the American Southwest. But it's a really good source of DNA, it turns out.